Greetings and welcome to the practice problem for the one sample t-test. I've already preloaded our screen here with some data, and this data represents time in seconds for ninth graders to complete 20 push-ups in a fitness test that's going on for maybe this PE teacher in a particular school. And there is a national average that we are aware of that says this is an appropriate level, or this is what the national average for ninth graders would be, which is 45 seconds. And so our hypotheses then become, the null is that your students are less than or equal to the average. And then, of course, if your critical t, if your calculated t is greater than your critical t, then you'll be able to challenge that null and say that your students have done better than the national average. So that's what this setup is kind of basically getting at. You want to know, as the PE teacher, if your students are doing at or below the national average, or if they're doing above the national average. And so what we have to do then is kind of run through the t-test in general. So let's just put back up what is our actual t is our x bar minus the mu that we choose divided by the standard error of the mean, right? So this is going to give us our calculated t here. So let's just kind of walk through this. So what is the total n that we have? The total n is equal to 8. Our new value, or degrees of freedom, is equal to n minus 1, which is equal to 8 minus 1, which is equal to 7. The mean here, which is driven by the formula you already know, which is the x from I equals 1 to n of all of these raw scores divided by the total n. Won't necessarily need to plug and chug all this. This is 45.21. Would encourage you to do this as well on your own. And so then going back, and I'm not going to do all these, but this is xi minus x bar, so this is just 42.7 minus 45.21. You're going to do the same for all these. And if you remember that this column should sum to 0, and then you're going to square these values over here, and then you'll sum this, and this value here is equal to some number. We call this actually the sums of squares, and if you sum that number, this sums of squares would be essentially the sum of the x minus x bar squareds, which is equal to let's see here, 18.8288, and this is in seconds squared. And then, of course, to get the actual variance is the sum of the x minus x bar squared divided by n minus 1. It's taking an average of basically this value, right? You're dividing by n minus 1 of the degrees of freedom, and you get 2.6898, and this is still in seconds squared. And then to get, you could just go from here and get the actual standard deviation if you want. I'm not going to calculate it, but if you remember this, it's just the square root of s squared. But we don't need this value. What we need is, go to blue here, what we need is the standard error of the mean. And the standard error of the mean calculation equals the variance divided by n, and take the root of that. And so we can calculate that simply as the 2.6898 divided by 8. Take the root of this. This is 0.58, and this is in seconds. So we've got everything we need now to calculate our t. So our t is our x bar, which is 45.21. That's seconds, minus the mu that we're choosing here, which is going back to our null hypothesis, which is 45 seconds, and then divided by this standard error of the mean term, which is 0.58 seconds. All of our seconds cancel. We get 0.36 unitless value for our calculated t. Right? And basically then what we need to do, so if you kind of remember our steps again, the generic step was, kind of restate into a null and an alternative. And then step 2 was determine the characteristics of the comparison distribution. And that's your new value, which is equal to n-1 for our one sample t-test. And so that was going to be a comparison distribution based on 7 degrees of freedom. And then we had to determine our cutoff on that distribution. And the cutoff on that distribution is t at an alpha that we choose, one-tailed, and new. So if we do this, we're generally, again, a convention is alpha is 0.05, one-tailed, and our new here is 7, which we had calculated from over here. So now we need to go find out what that number is. We do that by looking up in a table. I'll bring this table back over in just a minute, but it is 1.897. So that's critical C. So then we just have to create our inequality here. In this particular case, our calculated t, which is 0.36, is less than our critical t, which is 1.897. And if you remember, what is this kind of doing here? We're creating a comparison distribution, which is a t distribution, and we're saying that that in order to capture 95% here, our cutoff is negative 1.897 and positive 1.897. We're getting a value that's more like, if the middle here is 0, we're getting a value that's, 0.36. And we're saying that 0.36 is not on this side of the line, and we only challenge the null when values are on this side of the line. And since this 0.36 is not on that side of the line, we're not going to challenge the null, so we fail to reject as our decision. So I guess putting this back together, so 4 was, calculate t, and 5 was the decision. And then if I bring over and cut and paste, let's see here, edit, paste, bring this over here, switch to blue, and our t here was switch to blue. Our t here was 0.05, one-tailed. So here's our one-tailed row, and we go over here till we get to 0.05. So we're right here. And then our degrees of freedom, which was 7, is here. And then we look at the cross at those two rows, and there is our cutoff. 1.895 is on this chart. 1.897 is what I get in a table that's slightly more accurate than this, but close enough for what we need to do. And so that is the process of going through the one sample t-test. I hope you enjoyed this video.